Hello everybody, my name is Dr. Jaco de Tooy and this is a video memo for P00 or Practical 0 for the 2023 Computer Science Practicals. In this video, I want to, or let me rather give you a quick feedback or update. With P00, the main aim was to get you used to using the assembly assembler and the tool set that we've got available for that, and also using the debugger to debug our compiled or assembled applications, but also to get used to referring to the instructions presented or given to us during the lectures so that we know that we are using it correctly. Okay, now to help us with this, the practical basically describes a scenario where we want to calculate a grayscale value using the luminosity method. And basically what we do is we take three inputs, the red, green and blue values that's in the range from 0 to 255, and we multiply that with some kind of weighting. And the weightings in this case was 3 out of 10 for red, 6 out of 10 for green, and 1 out of 10 for blue. And that calculates as a grayscale value. And that's basically the idea behind it. For this specific prac, there's no way for us to actually supply these values using the keyboard or user input. So a lot of these values will be hard-coded as memory labels, meaning we're actually putting it into memory and we're using it. So let's start by actually going through such a process. There we go. And I'm going to demonstrate how I normally start with this, and obviously yours might be a bit different, but it might also be kind of the same. Who knows? Anyway, so there's two important sections in our coding area or in our template that's been provided to you. There's the .data section. This basically, whenever you add things in there, it will live inside the computer's data segment. And anything that goes under the .code area will live inside the code segment of your computer's memory. So these are just memory areas at the end of the day. So .data, we need three different inputs. We need one for red, one for green, one for blue. So I'm just going to create three little labels here. Each of these obviously pointing to a specific memory location. And I'm going to call mine int red. How much memory do I allocate for this specific label? I'm going to make mine a D word, which just basically means it's 16 bits. And I'm going to use the 224 value because here at the bottom there's a nice little table where we can actually give it certain values and we've got an expected result. So I'm going to use this one because it's got, and we can test it with zeros in just a minute, but 224, 82, 6, and we're getting some result there. So let's use that, 224, and then there's int red, blue, what's it, green, sorry, green, D word. So you'll see that I use Notepad++, but I mean, you can use whatever you like. I just don't want to be bothered with getting Visual Studio Code open and so on. I'm a bit more of a manual person. Anyway, that's got value of 82. The next value is blue. That's also D word. What am I doing? D word. And that's got a value of 6. And we're allowed, because this is what it says, you are only allowed to create global variables or memory labels for the terms specified above, red, green, blue, and the grayscale value, which is Y. So that is why I can actually use another label here, and I'm going to call it gray. Probably Y would have been a better word. I don't know. Sorry, my goodness. D word. And I'm not going to initialize it to a value. I'm just going to leave it empty. That's why the question mark is here. So the assembler obviously will read this question mark and not put a question mark character in there, but it will rather put it will leave that memory location intact. So whatever was there before is basically there. So this is kind of like an uninitialized variable. All right, so then we get to our start label, and anything that I basically add from this line onwards will go into the memory location allocated to the start label. And remember this public start. So when the linker links this thing into an exe file, basically the operating system looks for this label and it uses that label as one of the entry points for the actual user code for the executable file when it starts executing. So for this, what I'm going to do is we basically want to solve this equation. R read times 3 divided by 10. So I'm just going to, from left to right, type it in because that's exactly how you can do it. So for this, I'm going to need to understand how multiplication works. Now, when me as a person work with assembler, I typically, for each thing that I want to do, I follow a 3-step rule. Now, the 3-step rule is basically number 1, prepare the registers or the memory. Step number 2, execute the instruction. Step number 3, do something with the result, meaning get the answer. So those 3 steps. So to help us know what is important for the registers in the memory, we have to understand how we can do a multiplication. And for that, we can go to our instructions. Now, luckily for us, there's 2 instructions that we can use for multiplication purposes. The one is called mul, and it basically uses some kind of source, which is either a register or a memory location. And what it will do is it multiplies, if the source is 32-bit registers, it multiplies EAX by whatever that thing points to. So if we, for instance, prepare another register, EBX, as an example, with some kind of value, it will multiply the value that's in EBX with the value that's in EAX, and it will store the result in both EDX and EAX. So that's why we expect potentially EDX to change as well. So just be aware of that these registers do change. And remember, there's 4 registers: EAX, EBX, ECX, EDX. EAX stands for accumulator, EBX base, C is for counter, D is for data. But anyway, that's effectively what you can do. You can also use the imul instruction. The imul instruction uses a number of operands, and one of the easier operands is effectively this one, reg imul with reg and IMM. It will take the immediate value that you've got in there, multiply it with whatever value you've got in the register, and then the result will be, again, stored in EDX, EAX. Now, I'm going to choose just to use mul. Now, for this, that means I'm going to have to prepare this register. Remember our 3 steps? Prepare the registers or the memory. I have to prepare reg, and I have to prepare EAX. Now, what will be those 2 values? Well, it's these 2 values. Whatever is in R, I will put in the one register, and I will put the value 3 in the other register. Now, how do I put values in a register? Well, that is fairly simple. You can use the following instruction to do that. You can use the move instruction. So I can say move, and I can say move into EAX, comma, the value that's in int red. Now that means I'm using, if I go back to my instructions and I go to my move instruction, which is there, I'm basically using this syntax. I've got an immediate, which is, sorry, not immediate, it's actually a memory location there. Sorry, it's that one. The memory location is int red, because remember, int red is just a label that points to a memory location. And reg is the register that I want to move it into. So that's the syntax that I'm using. So int red into EAX. So that's, I've prepared one of the registers. Now I need to prepare my other register. And here I can, honestly, I can decide whichever one I want. Doesn't really matter. And I'm just selected going to be EBX. And I'm going to say 3 here. Now the reason why I use 3, remember, is because of this thing. 3 multiplied by R. And then all I have to do is I just call the mul instruction. So now I can just say multiply EBX. Remember, the mul instruction, you refer to one register, and this register will take 3, whatever value is in there, and multiply it by the value that's in EAX. So So this effectively does this. It basically makes int red multiply by 3. Okay, so that's effectively what this instructions do. And the answer, because that's my third step, so I've got my 3 steps: prepare the registers. Here I've done it. Run the answer, and then get the result back. And the result is in EAX EDX. So now that I know that it's an EAX EDX, I have to, the next step, divide it by 10. So EAX EDX is now where the answer is. And the main portion is obviously in EAX, because that's where the big answer is. Now, when you do a division, let's first figure out how that works. And again, I'm going to make use of the div instruction, because this is for unsigned data. All our data is positive, because we can't have negative 0 values and so on, negative red, green, and blue values. It basically divides the reg, the operand, with the divisor in EAX. Now we already have our the answer in EDX EAX, the big answer. And what we're going to do is we're now going to do the division. So the question that we have to ask ourselves is, did our original multiplication, because remember it basically takes the, although this one doesn't show it nicely, it actually does this as well. With a 32-bit divisor, it's a 32-bit divisor. It basically looks at both EDX and EAX as the number that we're going to divide it into, or that we're going to divide into. So EDX, EAX, and that means that hopefully we expect EDX to be 0, and or at least if it was a big number, then it will be in both of them. So at this stage, let's just quickly test our program and let's make 100% sure it works. So I'm just going to say create P00. There we go. And I'm going to just quickly start my debugger. Just give me a sec. All right, so the debugger is started. Let's open up a recent file. There's P00. And I'm going to see if I can zoom in there so that you can see a little bit better. There you go. And I'm going to just run to user code. There we go. And this is my first instruction. Move whatever value that's in into red, move that into EAX. And this is in data segment 040400. And you'll see as soon as I step over this instruction, inside my value, I've got the value of 224. And if you go back to the actual, well, let's just zoom out here. That's 224 that is loaded. Okay? Right now that we know what is loaded in there, oh my goodness, I struggle with this. There we go. Let's go to the next one. Next, I'm going to load, let's step in there. That's not it too. Step there. Load the value of 3 into EBX. And now I'm going to multiply these two numbers together, and both EAX and EDX should change. So have a look at what's already in EDX. Let's see if it actually changes. Step. And you'll see that the answer is EDX 000, and the answer is now into EAX. Now, if you use the div instruction next, it basically will just use this number as it is very nicely. IDiv, however, is a little bit different, because if potentially you've prepared EAX with the number and you have not prepared EDX with a very, very big number, then you have to take the most significant bit and move it into EDX, the most significant bit, or into EDX, and that's what CDQ actually does. Now, I'm not going to do that, so I can prepare, I can just basically use EAX, EDX as it is in my actual next div instruction, which is what's going to happen next. So I'm just going to stop this. Let's zoom out. Did this thing actually, yeah, it did. Right, there we go. So that is int red, and now I'm going to do the division. So I'm going to now say, basically EAX, let's call it EDX, EAX, divide that by 10, I think is the, was it? Let's just make 100% sure. Yeah, divide that by 10. Yeah, divide that by 10. So let's load, so for us, let's figure out how the div instruction work. Div instruction, we load, we have to remember our 3 steps, prepare the registers. EAX, EDX is now prepared, but we have to load some kind of divisor into the register. And I'm going to again just load it into reg. So I'm going to load 10 into my register, which is EBX. I'm going to use EBX as my register. So let's just do that. EBX, comma 10. That's an immediate, what they call an immediate. And now I'm going to do the actual division. So div EBX. And once I've done that, the answer will be in EAX, EDX. EDX, EAX. And then EAX will contain the quotient, and EDX contains the remainder. We're interested in this case in the quotient. Quotient. Okay, right, so the actual answer at the end of the day. Let's go and double check that it actually works. So again, created it, basically cleaning it. Let's go and load it. I'll zoom in just now again. Run to user. Let's zoom in here. This is not the latest version, sorry. It's not getting updated for some reason. Let me just see what's going on here. Like I said, just demonstrating, I've basically just opened my output where my exe files are created, which is normally under mas and bin. Opening P00, let's just open that again. Let's run to user code. And it's still old code. This is old stuff. Maybe it's because of debug information that's not updated or something. I don't know what's going on here, but this is definitely my old memo code that I'm seeing here. But effectively, it's exactly what's happening here. So I'm just going to again step through this. Let's zoom in so you guys can see. Step into, boom. Okay, loaded the value into EAX. Stepped, oh no man. Right, it multiplied EBX. The answer is in EBX, EDX. Now I load, some reason I did it. Sometimes you need to just prepare EDX again if you just do a simple division, but because we're doing multiplication and then division immediately after this step wasn't really necessary, and you'll see that in my notepad code, it's definitely not there. I prepare my register, which in this case is EBX, which is the value of 10. I'm going to do the division. And you'll see at the moment we've got our answer, which is the multiplication answer, which is 672. And you can go check that out yourself. And we're going to divide that by 10, which is 10 here. And so we expect 62 to be stored in EAX and the remainder into EDX. So let's just double check that. This, oh, 67, sorry, 67 is in there, and then the remainder is in EDX, which is a remainder of 2. Okay, right, so that's the division. Now that we've got the answer back into EAX, we need to do something with that register, because we can't just keep it there, because maybe if we use this pattern that we have, you know what, I'm not saving it, that's why. Let's try that again. Okay, anyway. But anyway, this pattern that we have, we're going to have to do something with the answer that's in EBX. And I'm going to just temporarily, because I haven't used the ECX register yet. So I'm going to use ECX register as my temp register. and I'm going to move the answer that I had from EAX into ECX. So basically just temporarily storing the answer in ECX. Okay. Okay, and that's the pattern that I'm going to use. And I'm going to do this for not just int red, I'm basically going to do it for everything else, except this last step will be a little bit different. So let's take the next calculation, next set of calculations, which is green times 6 divided by 10. So let's do that. So this is for int green, not gray, green times 6. So I'm loading int green in there into EAX. I'm going to multiply it by 6. There's the multiplication. And this will give me, again, the result into EDX, EAX. And I'm going to divide that by 10, which is exactly what I'm doing here. And then I get the result back into EAX. Now, in this case, I can't just move it into ECX. I want to add it. Whatever result I had. Remember, temp is like my temp. So instead I'm going to do this. Let's say ECX is ECX plus EAX. So how do I add those things together? Well, very simple. There's an add instruction. And you'll see here there's add. And it basically adds from the right to the left, and it leaves the answer into EAX as well. So if I just, so it's effectively this syntax that I've got, add the rightmost operand to the leftmost operand, leave the result into the leftmost operand, but also into EAX. And that's what's happening here. So add EAX is to ECX and leave the result. So let's see if this actually works. Let's save it. Right, let's run it. I'll zoom in just now. Recent, there we go. Zoom in. Hey, why am I not zooming in? Oh, I must use this button. There we go. So there's my first move from EA into EBX. So there's a step. Step, 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 step. I've got all of that. Here's my second move from where I now take the red value, load that into EAX. Step, and you'll see that EAX now has a value of 82, which is correct. According to my second, I load 6 into ECX. Off into EBX, I do the whole multiplication, the answer is into EAX, EDX. I now move 10 into EBX and I do the division just like I had before. Boom, boom. And now I take the answer that's in EAX. Remember, that's our resultant answer, which is 49. Currently to ECX, I've got 67. I add those together and the result will be in ECX and EAX. And you'll see that after this instruction, both EAX and ECX will have the same value. Boink. Oh, EAX was not updated, so not in that syntax. So ECX has the answer, which is 116. All right, and that's actually what we want. So we want to keep on doing this multiplication, add it to the temporary variable, and then once we've got the whole answer at the end of the day, we'll just publish that maybe back into some kind of label. So let's have a look at that and see how we do the rest. See, I always learn if I do these things. Anyway, so the next steps is it's effectively this. Red, green, this time for blue. In blue. And the value that I have to multiply is by 1. Okay, that's simple. So we don't actually even have to do the multiplication. But let's just do it anyway, because we already have the code there. But this was actually not necessary. We just had to make sure that, in fact, I'm not going to do it, because int green no, let's just do it. The int green value, multiply that by 1 is the int green value at the end of the day. Yeah, just it will make my code maybe a little bit more friendly if I do need to change it for whatever reason, these immediates. Do the multiplication, do the division by 10, get the answer into EAX, add EAX to ECX, and store it temporarily into ECX. And now that I've got it here, now I need to do something with the answer. move the final answer to int gray, because why not? So move int gray, comma, ECX. All right, and that will have the final answer into int gray. And we can go test this now and make 100% sure it actually works successfully. So file recent. Oh, I still need to first build it. I haven't built it yet. There we go. Run and zoom in and step. Step, step, step. There was the multiplication. There's the division. So there's our first round done. Temporary answer is in ECX. Now we're going to do the second round of adding and multiplying. So multiplying, do the division, add the answer into temp, do the same multiplication, do the division, add the answer into ECX. So the answer in ECX is 124. Let's just remember 124. In fact, let's just keep it like that, 124. Let's go back here. The answer is supposed to be 116. Okay, so I did something wrong. I'll have to figure out what I did wrong just now. So just give me a sec. Let me just figure out what I did wrong. Maybe it was a typo somewhere. Okay, eagle-eyed students might have seen this. I never updated this label. This would be int. What was it? Red, green, and blue. There we go. I never updated to int blue. That's horrible. Let's try it again. I need to just stop this before I can build. Otherwise, the file is in use. Build. Yep. Okay, zoom in so you guys can see. Step, 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 step. I want to get to that ECX section. There we go. Add to ECX. And now ECX has an answer of 116. Let's make sure that that is in fact correct. 116. Yes, it worked. So I can now basically also, if I want to, can just step through the rest, which is now adding it back into the label. So 0x for whatever that label. I think it's F7. There we go. And I can actually go here and I can say follow in memory map. I think. No. So there's the answer of 74, 116. So zoom in there. There we go. 116 is now the resultant answer of this memory location. So this was red, this was green, this was blue, and this was gray. Can you see the actual address is 0040400C? And if I go to the actual assembler, 0400400C. That's the place where it actually stores it. Okay, ladies and gentlemen, that is a very, very, hopefully shortish way of describing how P00 works. Please see what I did, learn from this, go practice it yourself if you did struggle on Thursday so that you can do better this coming Thursday. Thanks, bye-bye.